Ladies and gentlemen, we're going to integrate 1 divided by cos theta, and we get this crazy result, but the integral is actually not that bad. It's actually quite simple. And if we're not sure what to do, then try a u-substitution. Now, I chose u equal to cos theta first, and it didn't really get me anywhere nicely, so I did u equals sine theta, which is the one I'm showing you today. Now, if we take the derivative and rearrange, that gives us du equals to cos theta d theta. And now we can substitute in what d theta is. If we divide both sides by cos theta, d theta equals du divided by cos theta, just right here. And now it looks like we're getting worse, right? We started off with a cos, and now we have cos squared, but we're going to invoke a trig identity, one of the most famous ones. Sine squared theta plus cos squared theta equals 1. And cos squared theta in our denominator, cos squared theta is equal to 1 minus sine squared theta, but sine theta is equal to u. So cos squared theta equals 1 minus u squared. You see that? Hope you see that. So our integral becomes the integral of 1 divided by 1 minus u squared. And for those of you who have covered partial fraction integration, this is going to be very, very familiar. If not, I'm going to kind of describe it. I have lots of videos on this type of method, but what we're going to do is take this big happy fraction and split it up into two smaller fractions, one with 1 plus u in the denominator, the other one with 1 minus u in the denominator, and we just need to know what the numerators are. I put in a and b as placeholders. Now, to go from these two smaller fractions back, if we were to go back to the bigger fraction, we need to find a common denominator, right? And to find the common denominator for the a term, the term on the left, with the a in it, we multiply the top and bottom by 1 minus u. And to find the common denominator for the term on the right, we multiply the top and bottom by 1 plus u. So the numerator, when we merge these two fractions together, becomes a times 1 minus u plus b times 1 plus u. Hope you can see that. And that has to equal 1 because the numerator, when we merge these two fractions together, is 1 right there. Okay, now we have a few unknowns in here, so we shouldn't be able to solve for anything. It's just one equation, but the trick is that u can be anything. So we're going to set u equal to 1. And if we do that, this left-hand term cancels out, and we have b times 2 equals 1, so b equals 1/2. Now, you might think there's a problem here. U can't equal 1 in our fraction because we would be undefined if u was 1. But in our equation for the numerator, there is no restrictions for u. It can be any real number, so we can set it equal to 1. So if that seems like a discrepancy, don't hate the player, hate the game, but it works. Okay, so we're going to set u equal to -1 so that this term on the right cancels out, and then we have a times 1 minus -1, which is a times 2 equals 1, so a equals 1/2. They both equal 1/2, so if we substitute that in, we get this right here. Now, I factored our 1/2 out rather than leave it in the numerator. I just, for cleanness, I factored out, and then I pulled it out of the integral as well. And at this point, we're in familiar territory. The integral of 1 over some variable is equal to ln of that variable. We got to slap absolute value signs just to make sure we don't have a negative number inside the log, because u can be negative as a denominator. And if we do that, we have our 1/2, which is along for the ride, times ln of 1 plus u minus ln of 1 minus u. We have our absolute value signs there, and we have a minus sign because imagine you take the derivative of ln of 1 minus u. Well, the derivative is 1 over 1 minus u, but then we got to take the derivative of the inside function. We got to do the chain rule here, which gives us -1, which makes this positive when we take the derivative. So we take the derivative of this term, which ends up with a positive value because of the chain rule. Okay, plus our integration constant c, and we're basically done. We'll substitute back what u is. U is equal to sine theta, so we'll do that, substitute that back in, and then we'll do one of my favorite log laws, where if you're adding or subtracting logs, then you can multiply or divide. If you're subtracting, you can divide the arguments right here just to make it look a little bit cleaner. Good luck in the rest of your integral journey. You can do it. You can get through it. I know they're not easy to learn, but they will become familiar. The more you do, the better you'll get. I have tons and tons of videos to walk you through every step of the way. Hang in there. Good luck. Cheers.